In today's lesson, we're going to discuss reflections. So first, we have to talk about a couple of vocabulary terms. Let's first discuss what a transformation is. A transformation is any change to a shape's position, location, or size. Okay, next we have a preimage. Okay, preimage is whatever the shape is before the transformation takes place. Okay, so for instance, if I have a triangle labeled ABC, all right, triangle ABC would be the pre-image before it moves or flips or grows or shrinks. The image is what happens after the transformation.
Excuse the interruption at this time. Would you please?
Okay, so if I take triangle ABC and let's say I flip it, okay? Let's say I flip it over this line right here, and it would look something like this. Now A is flipped, so we're going to call this A prime. B is flipped. We call that B prime, and then C is flipped. Call that C prime. Okay, so this would be the pre-image again, and this would be the image. Okay. Next term is isometry. Okay. Two shapes have isometry if the pre-image is congruent to the image. Okay. So if it flips, it rotates, it slides, those are all going to have isometry. Okay. The only one that doesn't if the size changes. Okay. So if there's no size change, then we're going to have isometry. Okay. Finally, reflection is basically anytime you take a shape, a point, a line, and you flip it. Okay, you flip it over another line. Like the example above, this was an example of a reflection. Okay, because triangle ABC reflected, it flipped over this line here. And this line is called the line of reflection. Okay, so let's try some examples, all right? Here is two shapes, all right? One without the prime notation is called the preimage, again. And this guy over here with the prime notation is called the image. So what first thing we're going to do is we're going to list all the corresponding angles. Okay, so angle J, okay, angle J mapped onto angle J prime. Angle K, that transformed to angle K prime. And angle Q changed to angle Q prime. All right, so this is called prime notation, okay? Prime notation. Now let's talk about the corresponding sides, the sides that match, okay? Let's start with side JQ. JQ maps onto J prime Q prime. JK mapped onto J prime K prime. And finally KQ mapped onto K prime Q prime. That's how those things are related. Okay, the last example we're going to do is some coordinate geometry. Okay, we're given some points here. We're given J, A, and R. First thing I want to do is I want to draw the pre-image triangle JAR. So I'm going to plot these 3 points and make our triangle. So J is at 1, 4, which is right here. Okay. A is at 3, 5. 3, 5 is right here. So there's J, and there's A. And R is at 2, 1, which is right here. If I connect those, pretty bad triangle. There we go. We have triangle JAR. Okay, that is its pre-image, okay, before anything happens to it. Now what we're going to do is we're going to reflect this triangle first over the x-axis. Okay, the x-axis, okay, whoops. The x-axis is this line right here, okay? So what I'm going to do is I'm going to flip it over that line. All right? So R, for instance, is only 1 unit away from that line. So when I flip R, I get R prime. When I flip A, let's count how far that is away. 1, 2, 3, 4, 5 spaces away. So I'm going to go 5 the other direction. 1, 2, 3, 4, 5. That would be A prime. Now I'm going to go and take J and flip it over the x-axis. J is 1, 2, 3, 4 spaces away from the x-axis, so I'm going to go below it the same amount. 1, 2, 3, 4. That would be J prime. As you can see, when I connect the dots, you can see that triangle has flipped over the x-axis. Okay, next thing we're going to do is we're going to flip it over the y-axis. Here's the y-axis. That's this vertical line. Okay, so I'm going to do the same thing. I'm going to flip this triangle over that line. All right, so I'm going to do the same thing, except I'm counting the other direction here. J is 1 space away from the y-axis, so if I flip it over, it should land right here. That's J prime. Actually, we'll call that double prime, since we already had one before. A is 1, 2, 3 spaces away. So I'm going to line it up correctly. 1, 2, 3 spaces away. There's A double prime. I'm going to do the same thing with R. R is 2 spaces away, so if I move it to 2 in the other direction, here is R double prime. So if I connect the dots, you can see that the triangle has flipped and reflected over that y-axis. Okay, next we're going to reflect it over the line x equals 2. Now that line is a vertical line. Okay? So what I have to do is I have to graph this line. All right? It's a vertical line that goes through x equals 2. So every point on this line has an x coordinate of 2. Okay, here, right here, is x equals 2. So that vertical line goes all the way up and down. Okay? There's the line x equals 2. So now what I'm going to do is I'm going to flip each point over that line. Let's start with R. Now R is right on the line. So this point would stay put. And I'll call this triple prime. Okay? Because we already did 2 before. So R stays on the line of reflection. It doesn't go anywhere. A would flip over and land right here. And R would flip, or I'm sorry, J would flip over and land right here. And if I connect them, all right, that triangle flipped over itself. Okay? It actually like spun around it, all right? Kind of twisted. All right, so sometimes it's far away from the line of reflection. In this case, part of that triangle was right on the line of reflection. Okay? Finally, what we're going to do is we're going to reflect this original pre-image over the line y equals -3. This line is in the equation of a horizontal line. Okay? So I'm going to graph this line. Now this line is a horizontal line at y equals -3. Y equals -3 is right here. So every coordinate on this line has a y coordinate of -3. So that's going to be this line right here. Okay? That's the line y equals -3. So what I'm going to do is I'm going to flip this triangle over that line. Okay, so it's going to flip all the way over. It's going to flip right upside down. So I'm going to do the same thing I did before. I'm going to count how far each point is from that line and reflect it over the line. So let's start with R. R is 1, 2, 3, 4 spaces. So its image would be 1, 2, 3, 4 spaces away right here. That would be our quadruple prime, we'll call it. A is 1, 2, 3, 4, 5, 6, 7, 8 spaces away. So I'm going to count 8 spaces. 1, 2, 3, 4, 5, 6, 7, and 8 would be right about there. Okay, that's my new A. Finally, let's do J. J is 1, 2, 3, 4, 5, 6, 7 spaces away from that line of reflection, so I'm going to go the other direction, the same amount. 1, 2, 3, 4, 5, 6, 7 spaces. There's J quadruple prime. So I'm going to go ahead and connect the dots, and you can see that that triangle was reflected over that line. That concludes the lesson on reflections. I hope you learned something. Have a nice day.